Hello, everyone, and welcome back to the LefeWare Solutions channel, the place where we dive deep into the world of data and cloud technology. If you're new here, don't forget to hit that subscribe button and ring the notification bell so you never miss out on our latest content. Today, we're going to be diving deep into the world of data lakes and their pivotal role in enterprise data management. Let's get started. So, what exactly is a data lake? Well, data lakes have really emerged in the last couple of years as a very, very important component in managing the explosion of data volume, data variety, and data velocity, otherwise known as the 3Vs. And this is the typical data that any enterprise organization might produce. So just overall, a lot more data is being produced. It's coming in greater volumes and at greater velocity. So the data lake, it essentially provides a centralized reservoir, somewhere we can store it all, that allows these organizations to store all different types of formats. So store structured, think relational databases, semi-structured, think NoSQL, unstructured, think images and videos, and to do this all at scale. The data in the data lake it's analytics ready and it's capable of providing valuable insights. So for many of our enterprise customers at LefeWare Solutions, data it's just a key driver to strategic decision making. And when we set up their data lakes, we make sure that they're able to harness their data effectively, ensuring it's accessible, it's manageable, and it's ready to deliver actionable insights when they need it. And again, this is the real value in data lakes. Next, I wanted to provide a brief history of data lakes and essentially how they came to be. So before this concept of data lakes, organizations primarily relied on relational databases and data warehouses. These existing systems, they were structured, they were schema-based, and they were optimized for very, very specific use cases. Now, with the advent of the internet, social media, IoT, and other technologies, the amount of generated data absolutely exploded. Not only was there more data, but it also came in varied formats. So structured, semi-structured, unstructured. And these traditional data storage solutions that we've been working with, they struggled to keep up with this diversity and to scale efficiently. Now, around the mid-2000s, technologies like Hadoop emerged. And this allowed for distributed processing of large data sets across a cluster of computers with its Hadoop Distributed File System, or HDFS for short. This technology was more of a file storage system than a database. In HDFS, you don't need to define a schema before storing its data. This essentially means that you can store files irrespective of their file formats, whether they're CSVs, files, images, logs, any data format. So this is kind of where the term data lake was coined. It essentially described this new approach to data storage. Instead of like this organized and clean, structured water traditional databases, a data lake is more like a natural body of water where data flows in from various sources and paths and accumulates in its raw, unfiltered form, thus the name. Now, you're probably asking yourself, what differentiates a data lake from any other storage format? For example, a file system, AWS S3, or Azure Storage. Well, there are actually several key characteristics of a data lake and what makes them so special. So number one, the type of data that can be stored. So data lakes can store any type of data, structured, semi-structured, unstructured. I guess this is, again, doesn't really make it that different from other storage formats, but another one that really differentiates it is the schema flexibility. Data lakes support schema on read as opposed to schema on write. This means you can store data without a predefined structure and find the schema when you're actually ready to read or analyze the data rather than before storing it. Another thing is scale. Data lakes are designed to handle massive volumes of data, scaling from terabytes to exabytes, which goes beyond the typical capacities of traditional databases. Next up is raw data storage. Data can be stored in its raw native format. This contrasts with other systems where data often needs to be transformed or cleansed before it gets stored. Next up is integration with big data tools. Data lakes are typically compatible with big data processing tools like Hadoop, Spark, and many others. And this allows for distributed processing and analysis of the vast data sets that they contain. Cost efficiency. Many data lakes, especially those in the cloud, offer very, very cost-effective means of storing large amounts of data due to the optimized storage tiers and data compression methods. So again, all different methods that really make a data lake so special. So at LefeWare Solutions, we really focus on cloud-based data solutions. And one of the things that I love about data lakes is that nearly every major cloud provider offers their own version of data lake technology. And this is because they've become essential for storing these vast and varied data sets that organizations produce. They also have great integration points with other cloud resources that enable the required scaling for big data analytics, advanced machine learning, which modern businesses are increasingly relying upon for insights and innovation. So just to give some examples, Azure has Azure Data Lake. AWS has Amazon S3 with Amazon Lake Formation. Google Cloud doesn't have a specific service for data lakes like some of the other cloud providers, but you can actually build out this data lake architecture using cloud storage and BigQuery. And then there's also Databricks Delta Lake, which is an open source storage layer that brings ACID transactions to Apache Spark and big data workloads. This is actually, again, something that I want to cover in a different video. But as I said, great integration with other cloud providers. So now that we understand what a data lake is and how it came to be, I wanted to go over a real scenario where data lake actually came in very useful for one of our clients. So one of our large clients at LefeWare Solutions, they were actually in the manufacturing industry. They recently reached out to us because they had several different departments, each producing their own data in databases, their own logs, IoT data, etc. And it was a mess. They had a sales and marketing department, which had data related to customer preferences, buying behaviors, campaign outcomes, and they were mostly storing this in their CRM. Now, on the other hand, the finance department, they had a bunch of data related to sales, revenues, costs, and they were using a relational database. They also had an operations department, which had data related to inventory, supply chain, logistics, IoT device telemetry, and they just had, again, a bunch of different data stores where they were storing all this semi-structured and structured data. And then finally, they had a dev team that was building out a custom application for the inventory, I believe. And this app, it had log files, it had mobile and web analytics data. So again, just a lot of different data, each from its own department. So this organization, they had not yet implemented a centralized data lake, and they were facing several challenges. So each team I just mentioned, they would store and manage their data separately in different formats and on different platforms. And the data sharing between these different departments, it was cumbersome, it was time consuming, it involved a lot of manual processes, and there was often data integrity issues. In other words, there were data, like distinct data silos. So basically it led to having issues analyzing data across these departments because it would be complex, it would be challenging. It required a lot of integration of data between these different sources and formats. So ultimately, the organization, they really struggled to derive like these comprehensive, actionable insights due to the fragmented view of the data between all these different departments. So I actually kind of came up with just a quick diagram to kind of, I guess, display this issue of data silos. So as I said, this manufacturing company, they had a bunch of different departments. They had a logistics, they had a finance, they had a sales department, and then they also had a dev team. And obviously each one was storing data in their own way. So like, again, logistics, they had a bunch of invoice data that was just in a file system on a server somewhere. They're producing a bunch of IoT data, which I believe went to some kind of NoSQL database. Finance department, they had like an ERP system, where I believe it was like SAP. And they were mostly using like relational databases. Sales department, they had their CRM data, so like in Salesforce. They had a bunch of email data that they needed to track. And then the dev team, they had Google Analytics, I believe, which was where all of the insights for their custom web and mobile application, as well as a bunch of logs. And obviously each one of these departments, they want to be able to generate reports, provide business intelligence, like on how a certain department is doing, etc., do predictive analytics using machine learning. And obviously each one of these departments, they had their own way of doing this, but it was just for within that department. For somebody who maybe is a little higher, like an executive who wants to get a better idea of how the company is doing as a whole, or running cross-department type of queries, this was very, very challenging because each one of these there was permissions where, again, logistics department couldn't access financial information, and obviously they had it in their own data format. So somebody who knows SQL might not know how to access data in a NoSQL database, or vice versa. So really performing these cross analysis through at a company at a very high level proved to be very, very challenging for them. And they were just running into a lot of issues that became very evident by not having this centralized repository. So what we ended up implementing for them was a centralized data lake that all departments were able to push their data to. And this resulted in several of the following achievements. So first of all data from the different departments was now stored in a centralized, unified repository, regardless of its source, its format, or its type. That is one of the big advantages to the data lake. Next, data in the data lake could be accessed and analyzed by any department, enabling cross-functional analysis and insights. For example, like now the marketing sales team, they could easily access and analyze financial data to measure the ROI on different marketing campaigns. It also allowed for advanced organization-wide analytics, machine learning models, and AI that could be applied to the entire data set. And this essentially enabled the organization to derive more sophisticated insights and predictions, which is what they came to us in the first place for. Next up, data governance, security, compliance was now much easier to manage. It could be done more effectively at an organization level instead of being handled separately by each department, expecting each department to follow the organizational guidelines. Instead, just push it up to the data lake and then let the data engineering team handle that. So this is the actual solution that we implemented for this company. Obviously, I've simplified it quite a bit, but again, we can see each one of our departments is producing their own set of data. And what we're doing is either we are pushing this data to the centralized data lake, or again, we might have some pipelines here that are pulling that data in as part of some kind of batch job. But again, the main point is that all of our data is now going to be located in a centralized data lake, as we can see here. And there are several advantages to that. As I said, this allows for better data governance, data security, because instead of relying on each individual department to ensure these measures are being followed, we can just apply it now at this centralized data lake. And then now that all of our data is here, this allows for cross-department analysis at a company or organization-wide level. So essentially, we have all this data in the data lake. We can do some kind of ETL job, which, I guess I should mention that all this data is being sent in its raw format, so it's not really usable, but this is where these ETL pipelines come in, and they transform that data into a specific format that can then be loaded into some kind of data warehouse, where reports and different types of business intelligence, dashboards, etc., they can all be created. And somebody like a high-level executive could now come in and look at how the company is doing as a whole. So in this particular instance, for this company, we actually used Azure Synapse and Azure Data Lake to store all this data, as well as the built-in pipelines features that would transform it. And then, even though there wasn't much machine learning AI in this particular project, the data lake could also serve as a source for all of that data to be used in training machine learning models. So really a lot of benefits of having it all centralized here. So on my screen here, I have an actual Azure data lake. For the sake of this video, it really doesn't matter what the data lake technology is. We could have easily used AWS S3 or Delta Lake for Databricks. But again, from all other perspectives, it looks just like a normal storage account. But if we go down here, the way that the data lake is actually organized, it's kind of like a hierarchical format where in this case, we had several different departments all sending in data. Obviously, this is an oversimplification, but here we have our dev team, we have our finance team, we have our logistics team, marketing team. So each individual department would be sending their data, or again, we'd be pulling this data over into this centralized data lake. And then we can actually apply different permissions. We can change access levels. So this really sets us up for proper data governance, security, and really applying permissions at the specific level where specific users should have access. So let's just go into the logistics, for example. So under let's say the logistics department, they have a bunch of inventory data. They have some IoT plant data that they're sending in. And again, this is raw data coming in. So IoT, and this is a popular format for storing stuff in the data lake. Oftentimes you will partition it based on the actual date. So under 2023, we would, if I click that and go in, we would have all the different months. So we'd have like month 1, which would be January, month 2, which would be February, so on. For the sake of this would be October 27th. And then we would have, again, our data just stored in its raw format. This is a JSON file in its raw format, but really we can store anything in here. This could be images, this could be videos, this could be relational databases, this could be Parquet files, but really what I'm trying to show here is this hierarchy of how data is stored and how it is organized in the actual data lake. So if you're a growing organization that's looking to gain actionable insights from your data, you should be aware that implementing a data lake comes with its own set of unique challenges, like ensuring data quality, security, and governance. My team of dedicated data engineers at LefeWare Solutions can help implement and ensure your data solutions are using the most robust data governance, data encryption policies, and ensuring proper data quality and management procedures are being followed. To find out more, click the link in the description below. So in essence, data lakes have really transformed the way enterprises store, manage, and analyze their data, providing a flexible, scalable solution that can harness the power of big data. If you found this deep dive into data lakes insightful, do hit that like and subscribe button, share it for more tech insights. Have any questions or topic you'd like us to explore next? Leave a comment below. This is Josh from LefeWare Solutions, signing out.